In this section, we explore the profound influence of Donald Hebb and his groundbreaking work in the field of neuroscience, which laid the foundation for the development of artificial neural networks in machine learning. Our story begins in 1949 with Donald Hebb, a pioneering psychologist whose work provided a key insight into how the human brain processes information. In his influential book, The Organization of Behavior, Hebb introduced the world to a concept that would change how we understand both biological and artificial learning. Hebb studied the way neurons communicate with one another in the brain. He observed that neurons interact through electrical signals, and when one neuron frequently helps another neuron fire, the connection between them strengthens. This relationship was what Hebb described as neurons that fire together, wire together. He discovered that when one neuron continually excites the next, the axon of the first neuron develops synaptic knobs that form strong connections with the soma, or body, of the next neuron. This discovery laid the foundation for the development of artificial neurons and neural networks in machine learning. Hebb's observations provided scientists with the blueprint to simulate how machines could learn by mimicking the brain's communication patterns. Artificial neural networks, which form the backbone of machine learning models, are built to work in a similar manner to the neurons Hebb studied. Each node in a network can represent a neuron, and the connections between these nodes represent synaptic pathways. Through repeated exposure to data, these connections grow stronger, much like the biological neurons in the brain. Hebb also observed that when two neurons are activated at different times, their connection weakens. But when they fire together, their bond strengthens. This principle directly influences how machine learning models are trained to recognize patterns. The stronger the connection between nodes, the better the machine becomes at making predictions based on its training data. These early insights by Hebb led to the advancement of neural network research, which would later evolve into the deep learning systems that drive modern AI applications. Without Hebb's pioneering work, the very idea of machines learning from experience might never have taken shape. Donald Hebb's contributions to neuroscience continue to resonate today, both in our understanding of the brain and in the design of artificial intelligence. His work laid the cornerstone for one of the most important fields of study in the digital age, machine learning.